Now that we've worked with systems, we are going to start to dive into some applications of systems that we see in the real world. So, systems are used to find answers to real world problems, such as business, finance, economics, chemistry, engineering, weather prediction, and various other topics. This is due to the fact that they are the language that's used to model and solve complex problems where multiple interdependent factors are at play. So instead of isolating a single variable like we did in Unit 2, they enable us to analyze the behavior of an entire system. So when multiple things are at play and related to each other. So with that being said, let's just dive right into some examples. And let's get going. So for example, number 1, we have a coffee shop mixes 2 types of coffee beans. Type A costs $6 per pound and type B costs $9 per pound. Now they want to make 30 pounds of a blend that costs $7.20 per pound. How many pounds of each type should be used? So let's box the question because there's a lot of information going on here. So we want to know how many pounds of each type should be used. And specifically, we want to know how many pounds of type A should we put in this 30-pound blend and how many pounds of type B should we put in this 30-pound blend that'll make the cost average out to $7.50 per pound. Well, the first thing that we want to do when doing any problems, especially when we have more than just one variable going on, right? Because systems have the variable x and y, so we're going to have 2 variables, is we want to assign what each variable means. So I'm going to say x represents the labels of type A, of the coffee mixture type A. And y represents the pounds of type B. So now what we're going to do is we're going to figure out from this word problem what our 2 equations are going to be so we can set up that system. So for equation 1, what I'm going to do is I'm going to find an equation that represents the total weight of our mixture. And right, our total weight is 30 pounds. So we know for sure that this equation is going to be set equal to 30 because that's what our total weight is. It's equal to 30 pounds. And right, we're mixing 2 types of coffee. We're mixing type A and type B. So altogether, type A and B must be 30 pounds. So I'm going to do x plus y. And that's the first equation. When you add up the 2 mixtures together, they should equal 30 pounds because that's specifically what we're looking for, to make 30 pounds of a blend. So that's equation 1. Now equation 2. We are going to find the total cost. Or equation 2 is going to represent the total cost. So we know that we want this to equal $7.50 per pound, right? But the thing is this blend is 30 pounds. So we're going to need to take this $7.50 and multiply it by 30 to find the actual total cost. So I'm just going to write that here real quick. So we're going to say $7.20 is the cost per pound, but since we need 30 pounds, we're going to multiply it by 30. So when you do that, you get $216. Now that we have the total cost, let's actually set up the equation. So we know that this equation, I'm going to write the equation down here in this yellowish color. So we know that this equation has to be equal to $216. And we want specifically, we know that specifically type A costs $6 per pound, and we set up X as type A. So we're gonna say 6X plus 9Y. And that's because type B costs $9 per pound. So we're gonna say how much ever pounds of type B blend we have is going to be $9 times how many pounds, and 6 times how many pounds of type A. So now we have our two equations. We have this equation here that we set up earlier and this equation here. So now all we have to do is set up the system and solve for X and Y. So let's do that. So we have our first equation, X plus Y equals 30. And then equation 2, which we found over here, which was 6X plus 9Y equals 216. Now looking at this system, we can either do substitution or elimination. But in this case, I'm going to use substitution, and I'm going to set this first equation, X plus Y equal to 30. I'm going to solve it for X. So when I do that, you get X equals 30 minus Y. And now that we have this set equal to X, I'm going to simply substitute this expression that's set equal to X in for X here. So now what we're going to get is 6 times X, and X is 30 minus Y. And then we're going to add 9Y. And then we're going to set that equal to 216. And now we're going to just solve for Y. So our first step is to distribute in the 6 to both terms. So we get 6 times 30, which is 180. And then 6 times negative Y is negative 6Y. And then we're going to add 9Y. And we'll set that equal to 216. Now combining our Y terms, we have negative 6Y plus 9Y, which evaluates to 3Y. So we're going to get 180 plus 3Y equals 216. And then I do apologize because I did not leave enough room for this problem. But to solve for Y, we're going to subtract 180 on both sides and then divide by 3. And since we've had some experience with solving linear equations, I'm just going to say Y equals 12. And that comes from because we subtracted 180 on both sides and divided by 3. And now that we know that Y equals 12, we can go ahead and plug in the value of Y into either the first or second equation. But I'm going to plug it into the first equation because all we have is X plus Y. So that'll be easier to evaluate. So plugging in Y equals 12, I'm going to put that over here in blue. So when Y equals 12, plugging that in, we get X plus Y, which is 12, equals 30. And now we're going to subtract 12 on both sides to solve for X, and we get X equals 18. And now that we got that, we can write our final answer. So I'm going to write that. I'm going to write it over here. So the question is, how many pounds of each type should be used? So recall that X is the amount of pounds for type A. So this is our answer. So in the 30-pound blend, we're going to need 18 pounds of type A. And then for Y, that is type B. So that means we're going to need 12 pounds of type B. And there you go. You just solved a real-world application of systems of equations. Now, this idea can be confusing at first when you see it because there's a lot of moving parts. and it can feel kind of arbitrary, but once you get more practice in, it'll start to make a little bit more sense the more and more you practice. So looking at example 2, we have at a parking lot, there are 26 vehicles in total. Each car has 4 wheels, and each motorcycle has 2 wheels. Altogether, there are 47 wheels in total. Now we want to know how many cars and motorcycles are there. So this is very similar to our first problem, where we have a blend of 2 different types of things. We have a blend of cars with 4 wheels and a blend of motorcycles with 2 wheels. And we have this total mixture, or we have a total amount of certain wheels, and we want to know how many cars and motorcycles are there. So it's very similar to the first one. So with that being said, remember our first step is to assign variables. So we're going to say x is equal to the number of cars, and y is equal to the number of motorcycles. So now that we know that, let's set up our system, our 2 equations. Let me rewrite these brackets here. There you go, that's a little bit better. So for our first equation, we're going to have the total vehicles. And looking for at our first equation, we know that in total, there are 26 vehicles. So I'm going to set whatever this equation happens to be equal to 26. And we know that if we added we know that if we added all the cars and all the motorcycles together, that we'd have to have it equal to 26. So this first equation is just simply x plus y. And then for our second equation, we're going to figure out what our total amount of wheels are. And to do that, well, we know each car has 4 wheels, so we're going to multiply each car by 4, and then we're going to add 2y, because we know each motorcycle has 2 wheels. And then we're going to set it equal to 74, because that's the total amount of wheels that there are. And now that we set up our system, all we have to do is solve it. So, looking at this system of equations, since I did substitution for the first equation, I'm going to do elimination for the second example, just to get practice with both methods of solving systems. So, looking at our top equation, I'm going to multiply our top equation by -2. And the reason I'm doing that is so that our y terms cancel out. So, writing this out, we're going to have -2x minus 2y equal to -52. And then I'm just going to bring down that second equation. So we have 4x plus 2y equals 74. And now combining our like terms, -2x plus 4x is 2x. Our y terms cancel, and we're going to set that equal to -52 plus 74, which is 22. And now to solve for x, I'm going to divide by 2 on both sides, and we get x equals 11. And now that we know what our x value is, let's go ahead and plug in x to solve for y. So I'm going to do that up here. When x is equal to 11, we're going to plug that in to x plus y equals 26. So we have x, which is 11. And then we're going to add y and set that equal to 26. And now let's subtract 11 on both sides to solve for y. And we get y equals 15. So our final answer is that there are 11 cars, because that's what our x value, that's what our x variable represents. And then we're going to have 15 motorcycles because that's what our y variable represents. And that's your answer. Alrighty. So for example, number 3, we have, I actually encourage you to pause the video and try example 3 on your own. It's very similar to the previous 2 problems that we've done. And assuming you have given it a shot, let's go through it together. So we have a group of friends spent $195 on concert tickets. Some bought balcony tickets for $25 each, and others bought floor tickets for $35 each. If 7 tickets were purchased in total, how many of each type were bought? So the question is, we want to know how many of each type of ticket were bought. That's the question. So, as always, the first thing I'm going to do is assign what our variables mean. So let's say x is, I'm going to assign x as the amount of balcony tickets. And then y represents our floor tickets. Now I'm going to set up the system because we've assigned what our variables mean. So I'm going to write it over here. And for our first equation, I'm going to write the first equation to represent the total tickets. And we know that there's 7 tickets in total. So we're going to set our first equation equal to 7. And we know that all the tickets added together, the balcony and floor tickets, has to equal 7, right? So this first equation is simply just going to be x plus y equals 7. And then for a second equation, that's going to represent our total money spent. So to represent that equation, let's take a look. So we know for the balcony tickets, it costs $25 per piece. So we're going to say 25 times x plus 35 times y equals how many dollars in total did they spend? $195. So now that we have the system all set up, let's solve the system. So for this system, I'm going to do substitution. But if you did elimination, that's also perfectly acceptable as long as you got the same answer. So in this case, I'm going to solve this top equation for y. So I'm going to say y equals 7 minus x. And I did this by, if you subtract x on both sides, you get y equals 7 minus x. And now that I have this equation set equal to y, I'm going to substitute it in for y over here. So what we get is 25x plus 35 times y, which is 7. Oops. That's supposed to be 35, not 3y. 35 times y, which is 7 minus x, equals 195. And now I'm going to distribute this 35 in. So we get 25x plus 35 times 7 is 245. And then 35 times negative x is negative 35x. And we're going to set that equal to 195. And now, combining our like terms, 25 and negative 35, that's going to get us negative 10x plus 245 equals 195. And now, to solve for x, I'm going to subtract 245 on both sides. We get negative 10x equals 195 minus 245 is negative 50. And then to solve for x, I'm going to divide negative 10 on both sides. So we get x equals negative 50 divided by negative 10 is 5. And now to solve for the variable y, I'm going to plug in x equals 5 into this equation here, actually. Because remember, this equation is the same equation as this equation. It's just that I solved this equation for y. So now that I solved this for y, all I have to do is plug in the value for x. So I can get the value for y right away. So let's do that. So we're going to get here. When we say x equals 5, when we plug that in, we're going to get y equals 7 minus 5. Well, 7 minus 5, that's 2. So our answer is they bought 5 balcony tickets and 2 floor tickets. So they bought 5 balcony and 2 floor tickets. And that's your final answer. Alrighty, so for our final example, we have a scientist has a 20% acid solution and a 50% acid solution. How many liters of each should be mixed to obtain 30 liters of a 40% acid solution? So our question is how many liters of each. So we want to know how many liters of each solution should be mixed to obtain a 40% acid solution with a total amount of 40 liters. So as always, let's assign what our variables x and y are. So I'm going to say x represents the liters of the 20% solution. And y is going to represent the liters of our 50% solution. Now that we have that, let's just go ahead and start by setting up our system. So for our first equation, I'm going to set up an equation that represents the total volume. Now, we know that we need a total volume of 30 liters, so I'm going to set it equal to 30. And we know that we know that x, our 20% solution, and our 50% solution must add up all together to equal to 30 liters. So my first equation is x plus y equals 30. And then for my second equation, I'm going to set it up so it represents the amount of acid content. Now, looking at because x represents our 20% solution, I'm going to do 0.20 times x. Now, if that's confusing to you, this is why. So whenever you are converting percentages to a decimal value, or whenever you need to do computations with percentages, what you're going to do is take the decimal points, which is here, so we have 20, and you're going to move it over 2 places. So that's where this 0.20 comes from. So using that same rule here, moving it over 2 places, what would our y be in this equation? And I encourage you to pause the video to think about it. And assuming you have thought about it, this is your answer. So for a y, it's going to be 0.50 y equals, we want a what percent acid solution? A 40% acid solution. So what would our decimal be for 40%? That'd be 0.40. And now let's solve the system. Wait, I made a mistake. Can you spot that mistake? If not, no worries. So this 0.40, that doesn't represent the total amount of acid content because we need the acid, we need a 40% solution in 30 liters. So what we need to do is take 0.40 and multiply it by 30. So when we do that, we get 12. I'm going to just draw an arrow here in case, just for notation, so we know where this came from. So we have 0.40 times 30. So that's our system. And now to solve for it, I'm going to do substitution. And I'm going to take this first equation and solve for y. So to do that, when I do that, we get y equals 30 minus x. And then I'm just going to carry down the second equation just as it is. And now that this first equation is solved for y, I'm going to substitute this expression, 30 minus x, in for y. So what we're going to get is 0.20x plus 0.50 times y, which is 30 minus x, equals 12. And now, let's just solve for x. So I'm going to first start by distributing in the 0.5. So we get 0.20x. 0.5 times 30 is 15. Minus 0.5 times x is just 0.5x. We're going to set that equal to 12. And then now I'm going to combine our like terms. 0.2 minus 0.5 is negative 0.3x plus 15 equals 12. And now to solve for x, I'm going to subtract 15 on both sides. So we get negative 0.3x equals 12 minus 15 is negative 3. And then my last step to solve for x is to divide by negative 0.3 on both sides. And we get x equals positive 10. So now that I have solved for x, I'm going to substitute the value of 10 back into this top equation here. So what we're going to get is, I'm going to do that over here. So when we substitute in x equals 10, we get 10 plus y equals 30. And now to solve for y, subtract 10 on both sides. So we get y equals 20. So our final answer, now that we solved for x and y, is that we have 10 liters of our 20% solution. So that's the first part. We're going to have 10 liters of the 20% solution and 20 liters of our 50% solution. And that's your final answer.